Hello friends, in this video we will be discussing a problem regarding capacitors, and this problem was also asked in NEET 2023 physics. In this problem it is shown that a capacitor is connected across an AC source and we are asked to find the correct statement among these. What will happen to the parameters of capacitor when the frequency of the source decreases? Displacement current decreases, capacitor reactance remains constant, or capacitor reactance decreases. To know the correct statement, we must be familiar with displacement current represented by ID and XC capacitive reactance and their relation with the frequency. So let's solve it. In case of capacitors, when a capacitor is connected across AC source, two types of currents flow. One is a conduction current that flows in all other circuits, and one that is a current due to the electric field in the space between the two plates. The displacement current, this term was first introduced by Maxwell. Maxwell said, we know when a current flows through a conductor, a magnetic field is generated around it. Since current is just flow of charges and electric field is associated with each charge, so changing electric field creates a magnetic field. So why cannot a changing electric field here create some current? Though that current is not due to the charges, flow of charges, that is due to the changing electric field. Since we have AC source here, AC current will change its direction after every half cycle. For first half cycle, we assume the charge on the capacitor are appear in this fashion, so electric field will be in this direction. When second period comes, the direction of current reverses, so charges will redistribute in opposite way, so the electric field will be oriented opposite to initial position or initial fashion. So this will continue happen until current flows through this circuit. So electric field here is changing every moment, so this changing electric field can create this magnetic field, and that magnetic field is equivalent to or equal to the magnetic field created by or generated by conduction current. So Maxwell said that conduction current is always equal to displacement current, or displacement current is equal to conduction current. What is this current? Current is the flow of charges per unit time, and we know for capacitor, charge on capacitor is given as capacitance of the capacitor times the voltage across the capacitor. Voltage here in this case, V is AC. We can express it as V naught sine omega t. So our Q will be C V naught sine omega t. Thus ID equal to ID is differentiation of this charge, that is C V naught sine omega t. These two terms are constant, they will come out, there is C V naught, and differentiation of sine we know is cos, and there is internal term here with t, there's omega, its differentiation will be omega t, its differentiation will be omega, that will come out. So we got the expression for displacement current as C V naught omega cos omega t. So ID is C V naught omega cos omega t. Now we have to tell what happens to ID when omega decreases. Since this cost function, when omega decreases, the time period of function will increase. So its graph will be like this, but no impact will be on the magnitude of this function. It assumes values between -1 and 1. So this term will have impact on the magnitude of current. So we get ID will be proportional to C V naught omega. These two terms are constant. So when omega increases or decreases, that will directly decrease or increase ID. So omega decreases as is told in the question, ID will decrease. Also from this equation, we can get capacitive reactance C V naught omega cos omega t. We can write it omega naught over 1 over omega c cos omega t. ID is V naught over x c cos omega t. So xc is 1 over omega c. C is constant, omega is varying. So whenever omega decreases, xc increases. Coming back to our options, what we learned, id is directly proportional to omega and x is inversely proportional to frequency. So when frequency decreases, id will definitely decrease. But in this case, reverse will happen. When this term decreases, xc will increase. There is no such option where xc increases. It is said that it remains constant or it decreases. So these two options are not correct. Since displacement current is proportionally equal to this frequency, decreasing frequency decreases displacement current. So option 2 is the right option. Hope you understand this.